Le monde moderne ne repose pas sur la magie, mais sur des systèmes physiques. Des câbles sous-marins aux agents autonomes, notre quotidien dépend de couches invisibles. Bienvenue sur ma chaîne. Fasciné par les capacités exponentielles de l'IA, je consacre ce canal à décortiquer ce qui se cache sous l'interface.
Bienvenue à bord.
Welcome to this explainer. Look, today we're going to unpack a really fascinating architectural friction. We're looking at how a system called the compliance scanner actually navigates the massive, almost paradoxical gap between rigid European Union laws and the inherently fluid nature of artificial intelligence. Let's just dive right into the core intellectual tension here. I mean, can a machine that inherently guesses actually evaluate laws that demand absolute certainty? We're talking about relying on a probabilistic large language model to assess strict, uncompromising legal codes. On the surface, that sounds like a total recipe for a compliance disaster, doesn't it?
And this right here illustrates our baseline friction perfectly. On one side, you have 5 incredibly demanding, deterministic European frameworks: GDPR, DORA, NIS2, Schrems II, and the EU AI Act. They require absolute binary certainty. But the engine powering the scanner? It's Google's Gemini 2.5 Flash. That's a non-deterministic, probabilistic machine. It calculates the most likely next word. It doesn't actually know the law in a strict coded sense.
Section 1. A single prompt solution. So how in the world do you force a statistical model to spit out a reliable legal audit? Well, the answer actually lies in the sheer simplicity of the input constraints. Traditional compliance tools can literally take weeks to set up. But here, there is zero onboarding, no OAuth connectors to mess with, absolutely no access needed to your internal IT systems. You just enter one single input, the name of a third-party SaaS tool like Notion or Slack. In return, the system evaluates it against all 5 of those massive EU frameworks in one single API call and gives you a structured JSON object, all without ever touching your internal architecture.
To figure out how it reaches that verdict, we have to break down its internal engine, which is called Protocol C. Think of it almost like a sonar sweep over public data. First, it collects, fetching publicly available URLs, things like terms of service and data processing agreements. Second, it correlates those signals against EU obligations using really strict system instructions. Third, it classifies the risk, emitting a clear red for prohibited, orange for conditional, or green for compliant. And finally, it capitalizes by locking that JSON output and generating a structured PDF report.
Section 2. Forcing system consistency. Okay, but we have to address the elephant in the room here. If the underlying LLM is inherently non-deterministic and prone to hallucinating, how does the system stop 2 different users from getting completely different legal evaluations for the exact same software on the exact same day? The answer to that lies in this architectural anchor, 30.
This is our cache anchor. It's absolutely crucial because it forces consistency in a total sea of fluid variables. Basically, it's a 30-day system lock, a time to live stored in a Firestore database. When you scan a tool, that non-deterministic output is frozen. For the next 30 days, any subsequent audits for that exact same tool hit the exact same cache JSON verdict rather than generating a new, potentially completely different LLM response. It effectively builds this temporary deterministic bridge right over a non-deterministic engine.
Section 3. AI as statistical triage. Which brings us to defining what the compliance scanner actually is in the real operational world. And look, we must acknowledge the system constraints. This tool is not replacing your heavy fleet of compliance automation. There's no continuous automated proof collection. It doesn't fulfill DORA Article 28 registry persistence requirements. It doesn't integrate with your internal security event managers. The reports are unsigned, meaning they hold absolutely zero formal probatory value in a court of law. And of course, those known LLM hallucination risks are still there. It's an observer, not a legal validator.
Now, when you stack the scanner directly against traditional governance, risk, and compliance platforms, your Vontas or Dradas, the distinction becomes crystal clear. The scanner lives purely upstream. It's an early warning radar for AI governance and first-pass triage. It perfectly complements, but critically does not replace, the continuous, deterministic proof collection of those traditional platforms. Basically, you use the scanner to map the horizon, and you use your GRC platforms to actually secure the internal systems.
Section 4. The operational reality.
Let's crystallize this. What should you actually take away from this technical architecture for your own compliance workflow? Think of the scanner as mapping the terrain to identify major risks immediately. It highlights the red flags and gives you operational intelligence in seconds. But what that really means is you only deploy your expensive manual auditing efforts, your legal teams, where the radar actually shows a red or orange anomaly. Human operators absolutely must still verify the depths against official signed data processing agreements. Ultimately, the entire thesis of this architecture boils down to this. AI is a statistical triage filter, not absolute legal proof. We can absolutely leverage probabilistic machines to navigate deterministic laws, but only, and I mean only, if we treat their outputs for exactly what they are, operational intelligence, rather than the ultimate legal truth. So, as you go out and architect your own compliance pipelines and start integrating these new AI tools, I want you to consider this. When facing incredibly strict EU regulations, how will you integrate first-pass AI triage while still maintaining the absolute certainty the law demands? It's really not about choosing between the radar and the manual check. It's about knowing exactly when to use each to build a truly resilient system. Thanks for joining me on this explainer, and I hope this gives you a much sharper lens on AI governance.